Hello, welcome to today's lesson, our last one in this particular set. So this one is all about mixtures. We've been talking about a variety of things in this unit, about atoms, elements, and compounds, about pure substances and mixtures, homogeneous and heterogeneous mixtures. So this one kind of wraps it up with talking about how to get the parts of a mixture kind of taken away from one another. So not just how to make it, but how to kind of undo it, I guess, as the case is. So this little picture here, I saw this a few weeks ago. And it really surprised me to see this young girl leaning over and drinking water directly out of this disgusting basin of water. And I, number one, was really happy that the stuff that comes out of my tap is clean. But then I was kind of wondering, how is this possible that you could actually drink water that looked that nasty? And I'm not Bear Grylls, so I don't do that regularly. But anyway, so this girl is using something called a life straw, which is a really interesting new piece of technology that's out there. And they're taking them all over the world to help people that don't have access to clean water make clean water in a very simple way, very down to earth. And the basic science behind this is the simple fact that the dirty water that she's trying to drink is actually a mixture. That mixture of water isn't just pure water, or she wouldn't have to clean it, but it's got a bunch of different things in it. Some things are good, some things are bad. And the life straw is really easily capable of separating those components. So it can take out the dirt and some of the other pollutants that are in there and just pull through the clean water. And that's actually what the girl is drinking, and all the other pollutants are left behind. So it's kind of the idea of separating a mixture. What process is she actually using, or is the life straw actually using, to be able to turn that nasty, disgusting water into clean, drinkable water? And it's pretty cheap and pretty easy with those. So a little quick review here on some basic vocabulary. What's a mixture? What are the components of a mixture, etc. So remember, a mixture means that you have more than one thing, and they're all sort of thrown together in the same container. Not reacted together, but mixed up. And they could either be mixed up kind of in a bulk sense, that would be like a heterogeneous mixture, where you can see individual particles, or maybe there's different phases of something that are present, like a liquid and a solid. It's kind of a weird idea, but if you have mud, for example, that would be a heterogeneous mixture, or a homogeneous mixture, where one thing is dissolved in something else is the most common type of homogeneous mixture, like a solution is a homogeneous mixture. Key idea here is that it's chemical processes that put these two things together, or more things than that, but it's also chemical process that can then take those things back apart. No chemistry is required for this, so we're just going to take a look at the physical processes that we can use to combine and then uncombine these different compounds. And I do wonder why these two girls at the left are wearing safety goggles to make their hot chocolate. Anyway, so for example, some of the easy stuff, and we'll get into some more actual interesting ones in a second, but when we're trying to separate the components of mixture, a lot of times we can just do basic stuff, especially heterogeneous mixtures. We can take them apart based on real simple physical properties like the size of the particle, shape, color, texture, some of those sorts of things. If you had your, looking at your laundry, could be a mix of, say, dirty and clean laundry. And you could separate those by the physical property of, say, odor. God, I hope not. But you could just sniff one, clean. Sniff the next one, ugh. Simple physical separation. The picture in the top left is actually what gold looks like when they do gold panning. And they're using a physical process, actually two of them, to separate the gold from the sand underneath. Usually black sand has gold particles in it. So you can use the process of color. Obviously, they look very different. But also, if you've ever seen someone gold panning, they tend to like swirl this big container of water and sand. So they're actually taking advantage of something called density. The gold's heavier than the sand, and so you can kind of get rid of some of the sand that way. So some of those kinds of things, really easy ways to separate components of a mixture, obvious ways. Some less obvious ones, one on the thing at the bottom here, magnetism. We tend to forget that that's out there, but if you've got iron or iron-containing compounds in something, you can simply use a magnet to get the stuff out of there. So if you've ever done this outside, if you've ever dropped a magnet in the sand, you'll find that actually iron ore is very common, little tiny flakes of it, really common in the dirt, at least where I live. And so if you drop a magnet in there, it's going to automatically grab all of that iron. So anyway, there are some less obvious ones that we'll talk about in a second. Also physical properties. So remember, physical properties include basic characteristics like things that you can see, smell, taste, touch, etc. But it also includes some less obvious things like the temperature required to do a phase change. Is it a solid, a liquid, or a gas? And what temperature does that happen at? Density, whether something sinks or floats, or whether it's heavy or light for its size, is another physical property. And then solubility is a physical property that we'll take advantage of here. Does it dissolve in water, or does it not dissolve in water? And both of those can be important. So, number one, we use this all the time in chemistry class, filtration. And that's actually what the life straw takes advantage of. Filtration takes advantage of the physical property of size. When you're talking about filtration, like if you maybe made coffee or pasta at your house, you're doing a type of filtration where you've got something that's porous that a liquid can pass through or dissolved particles can pass through, but the bigger, chunkier stuff gets held behind, and that's what a colander is or a coffee filter is. In a chemistry text, chemistry situation, we'd have a setup kind of like what's in there with a funnel, with a very special piece of paper in there, a type of filter paper. There's really small holes in it, very, very tiny, you can't even see it, but the clear liquids or dissolved substances, so solutions can pass through, but solids cannot be passed through, and they'll kind of be kept behind or held behind in the paper. There's actually different types of filter paper, from big to very, very, very fine, very, very slow. So filtration, really important process. We'll use it probably in a bunch of labs that we do this year. Number 2, a little trickier, something called distillation. If you've heard of this before, if you've ever seen someone with a still or seen TV shows about this. Distillation takes advantage of boiling point. We're going to heat up a liquid that contains something like salt and try to drive off the water. Or drive off whatever has the lower boiling point to it. So if you can imagine this diagram that's up here, over on the left, for example, it says there's a distilling flask. There's some sort of a pinkish liquid in there that we're heating up. And one of the components of that is going to turn to a vapor, and it'll kind of lift up. Usually vapors are lighter than air. And then we capture that vapor somehow. And there's a lot of bigger and smaller and more complex and less complex ways to do this. This thing that they have in the middle here is called a condensing tube. You can just use just tubing of any sort, but something to kind of capture that vapor, let it cool back down, and then that vapor will cool down and drip out on the other beaker, which is the distillate, is what they call that. So like for example, if I did this with salt water, the beaker on the left would have salt water in it, water vapor would lift up, travel through the condenser tube, and then just pure water is going to drip down the other side. All of the salt will be left behind in the original container. So again, this is the method called distillation, taking advantage of boiling point, heating up one thing, turning it to a gas, and then letting it recondense or recollect somewhere else, leaving behind something that's probably something that you don't want. Here's an application of this. This is called fractional distillation, so it's just a slightly fancier of repeat distilling at different temperatures. This is how your gasoline versus oil and different things like that get separated. When they pull crude oil or these sort of crude petroleum products out of the ground, they'll run them through a really big refinery condenser of some sort and heat up this mixture. And you can see kind of from top to the bottom in this, there's different temperatures. So things like petrol, gasoline, and bottle gas come off very quickly. You only have to heat it up a little bit for those vapors to be driven off. They collect that in a container and then take it away. They take that next mixture, heat it up a little bit further, up to say 110 in the middle, where you get some other types of chemicals like naphtha is the one that they list on there. 180, heat it up even further, and kerosene is going to start to come out. And again, that's a different type of a fuel that they would use. And you could condense that, heat it all the way up even further and further, and then the stuff that's left behind, the sludge, we call it bitumen. In America, we would probably call that asphalt. They use it as the black sticky tar that's nasty and left behind. So the bitumen is usually the stuff that's left behind in the original container. So again, just an application of where you've used this particular, or seen this, or benefited, I guess, from this in something in your real life. So distillation is one of the tools that we use. All right, method number 3 is actually the process of crystallization. We're trying to collect the solid now as opposed to collecting the liquid, and we usually use evaporation this way. We can do it faster, we can do it slow. So either way, we're still trying to vaporize something kind of like distillation, but now we want to heat it up until all that's left behind, the dry stuff, is what we really want. So in this case, you can see there's a laboratory burner with a blue liquid in it, and you heat it up, drive all the liquid off, and eventually, after all the liquid is gone, the stuff that's left behind would be your chemical that you want, your crystals. In this case, it's a copper sulfate. But that's, like I said, a fast way to do it. Slow way to do it. It's the picture at the bottom left, that's rock candy. So if you've ever made that before, you take a solution of lots and lots of sugar and some water, you leave the container open, let the water evaporate out, and then eventually the sugar crystals will kind of condense out depending on solubility, basically. The water can only hold so much sugar or so much anything at a time, and they'll start to form. So again, that idea of evaporation and leaving behind the crystal, slightly different than distillation. Distillation, you want to capture the vapor usually. With crystallization, you want to capture the solid. So they're closely related, not quite the same. A second one related to this is this idea of fractional crystallization, kind of like the fractional distillation, where you've got more than one solute, more than one solid that you want to recapture. And I just put this on here as just kind of a further example of something that happens with this. So if you have a solution that contains two different things that you've dissolved in it, number one, if you let it cool down, The one that's least soluble will actually crystallize out first. You'll get those little crystals start to form. And then you can remove those crystals, let it cool down even further, and then a second set of crystals will start to form. Where you have this experience with this, whether you know it or not, it's actually from geology. This is how igneous rocks tend to form over time. Where if you've got magma, that magma cools very slowly over time. And for example, the first thing that tends to form for magma cooling is this chemical on here, this rock on here called olivine, beautiful green crystals. And then later on, other types of things like plagioclase and orthoclases will start to form as that magma cools down even further. But it's a type of fractional crystallization to form rocks. Okay, method number 4, last one we're going to talk about, I think, today, is a way that we can deal with liquids. How do we separate liquids from one another? This thing is called a separatory funnel. It's kind of a weird-looking diagram. You may have seen one in your kitchen called a gravy separator. Same thing, separatory funnel. It's actually called liquid extraction. This is a process that's used a lot of time either with petroleum products or with organic chemicals, which are oftentimes, petroleum products are organic. But this is based on the idea of density and solubility. So these two liquids maybe don't dissolve in each other very well, and so one of them floats on top of the other. So you have kind of an advantage here. There's a spout in the bottom of that separatory funnel. You can open it up, and you can drain out that heavier stuff that's at the bottom. If you're doing it at Thanksgiving, you're draining out the gravy, which is the heavier component, and leaving behind the oil that maybe you don't want. So again, it's just another way to separate two liquids from one another as opposed to trying to vaporize or crystallize something. So there you go, common laboratory methods to separate different kinds of mixtures. So there's some easy ones and some more complex ones. So number one, just as by way of review, you should be able to state the characteristics of a mixture, in terms of stating the characteristics. Is it homogeneous or heterogeneous? What are the phases that are present? You should be able to explain why physical methods versus chemical can be used. And again, remember, we're only mixing them together physically, so we should be able to separate them physically. Sometimes it's really easy, like pick out all the red ones, or sometimes you have to do some fancier stuff. The fancier ones that we're looking at here, the 3 big ones that I want you to kind of take away chemistry style, are those processes of filtration, distillation, and crystallization. So can you explain how the process works? Could you show me what a lab setup was? And then could you maybe tell me what property is being taken advantage of? Like this is filtration. We're using solubility. I dissolve something in water so it would pass through, and particle size. The big ones are held behind. And then last but not least, if I give you a mixture, like a hypothetical mixture of sand, salt, and iron, what kinds of, could you brainstorm, could you explain what kinds of processes could you use to separate that mixture in such a way that you'd have all 3 components still present and separated from one another at the end? So there you have it, separating a mixture, some of the characteristics of mixtures, and some of the different techniques that we use. See you next time.